Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. And today, we'll be looking at the natural logarithms. That is, the natural log written as linear. This is the differentiation playlist, and make sure you subscribe so that you don't miss out on any of our future uploads. This is part 16. And make sure that you go over all the other parts prior to this part. This could be beneficial. And once again, you can check out all the other playlists that we have so far. Now, moving on with the natural logarithms. If y of x is equals to ln of x, then the dy dx becomes 1 over x. And in general, if y of x is equals to ln of f of x, then the dy dx becomes f prime of x over f of x. Now let's derive this just to be sure about what we are talking about. So if y of x is equals to ln of f of x, and using the chain rule method according to video part 3, and I encourage you to check it out in the differentiation playlist, there is a lot that we covered. We can see that we can actually let the inner function within the ln function, that is the f of x, be u, implying that the du dx becomes f prime of x. Then the second step would be, since we have substituted for f of x, the y becomes the natural log of u, or ln u. And we know from the first step on the left-hand side, dy du becomes 1 over u. Then step number 3. This would then mean that the dy dx is given by dy du times du dx, and substituting for the dy du that we obtained in step number 2, which was 1 over u, and the du dx which we obtained from step number 1, which is f prime of x, we are going to get that. And of course, from step number 1, we know that u is equal to f of x. Substituting back, we are going to get the dy dx being f prime of x over f of x, and that is shown. So that is what we'll be using throughout the examples. Great, then, so we have example 1 given y is equals to ln of 7x. Find dy dx. The solution. Y is equals to ln of 7x, or ln 7x. Then we know and see that the f of x, the inner function, is 7x. So we are going to have f of x being 7x. Then the derivative of that f of x is f prime of x, which is equal to 7. Therefore, we know that the dy dx of ln is given to be f prime of x over f of x. Now we substitute for the f prime of x and the f of x that we obtained earlier on. The f prime of x was a 7 and the f of x was 7x, and we know that the 7's will cancel out so that our dy dx becomes 1 over x, and that will be our solution. Now let's look at example 2. We are given that y is equals to ln of 5x plus ln x. Find dy dx. So the solution. We have the y, which is given to be that. And within the ln function, we are going to take that and make it the f of x. That is to say that the f of x is 5x plus ln x, which is the inner function within the ln function. Right, so the amazing part is within the ln function, we also have a ln function, and that is amazing. Then the f prime of x will be given by differentiating the terms individually. 5x becomes 5, ln x, according to what we have on the left-hand side, becomes 1 over x. Therefore, f prime of x, if we are going to combine the two terms to be one fraction, we are going to have 5x plus 1 over x. Then the dy dx, which is f prime of x over f of x, by substituting for the f prime of x of 5x plus 1 over x, going to the numerator and taking the f of x to be the denominator, we would have that. And of course, it's not a great thing to leave our answer in this manner. We have to simplify our fraction. So we can simplify our fraction in this manner. So our answer is given as that. Now let's take a look at example 3. With example 3, a curve has equation x is equal to 1 over 5 times e to the y times 2x minus 3 plus 4. Find the dy dx when x is equal to 1. As you may recall, we are used to dealing with the equations that have y as the subject of the formula. But this time around, we have an x. So the first thing, of course, would be to make the y the subject of the formula. In doing so, we need to make sure that we remove the terms up until we get what y is in terms of x. So we see that we can move the 4 to the left-hand side. That one is easier to move. And it becomes negative as it crosses the equal sign. Then we see also that we have an exponent on the right-hand side. The best way to deal with an exponent would be to introduce the natural log. So whatever we do on the right-hand side, we must do on the left-hand side. So we introduce the natural log on both sides. And that's how we would introduce the natural log. And also, it is important that we recall one thing. From ln e to the x, that would give us an x, implying that the ln and the e would sort of cancel out. Then with that, we still have the left-hand side the way it was, but the right-hand side loses the ln and the exponent, so that we have that being equal to y times 2x minus 3. And of course, to detach all the other terms from the right-hand side so that we're left with just y on one side, we are going to divide throughout by 2x minus 3. In so doing, we get the answer as y is equals to ln of 5x minus 4 all over 2x minus 3. So now that is our y. Now recall from the product rule that we covered in part 13. In as much as one may use the quotient rule, that is okay, we'll still come up with the same answer after all. But I'd go with the product rule. Now, we are going to let the numerator be the u, which is ln 5x minus 4, and the denominator be v. But now we won't treat it as a denominator because we are going to raise it to the power minus 1 so that it becomes a product. We've got two parts that are multiplying each other, two terms that are multiplying each other. Now, I encourage you to also check out the quick and easy chain rule part 12 video where we spoke about how to deal with the terms that are of the manner of v. We covered a lot of ground on that. So this would mean that u prime becomes 5 over 5x minus 4. This we get it from the formula that we're now using of differentiating the natural log, and the v prime would be given by that. So now simplifying that further, we are going to get the v prime of minus 2 times 2x minus 3 raised to the power minus 2. With that then, it means that the dy dx becomes 5 over 5x minus 4, 2x minus 3. Then we also have the other bit right there. Now, so if this is not making sense, I encourage you to check out the product rule part 13. We cover this in great detail. And of course, now that we have obtained the first derivative of y, we can now substitute for x. Wherever we have x, we substitute with a 1 so that we get the value of the dy dx when x is equals to 1. Right, so this is what we're going to do. So wherever I have x, I've just substituted with a 1. Simplifying further, we are going to get a minus 5 minus 2 ln 1 now. And we know that ln 1 is equal to 0, implying that our final answer becomes a minus 5. So if you have made it thus far, I say congratulations to you. And I leave you with the following task. Make sure to write your answers and even questions in the comment section. We will be there to assist you where possible. Thank you so much for watching Numbers Simplified. Make sure that you share, like, and subscribe so that you don't miss out on any of our future uploads. Remember once again, God loves you.